All right, in this unit, we're going to remind ourselves about complex numbers. If you recall, complex numbers mean it contains an imaginary unit of I, and we defined I as the square root of -1. So if you square I, you get -1. And so this relationship is what you need to remember. All right, when complex numbers can be written in what we call standard form. If they contain a real portion, A represents a real number, BI represents the complex part of the number. So if you have a mixture of real and complex, then this is what the form looks like, A plus BI. So the complex part sits in the back. So look at this example, square root of -9 minus 5. Now, square root of -9 can be rewritten. Square root of 9 is 3. The square root of the -1 part is I. So I could write it like this, but this is not considered standard form. Standard form would put the real portion first and the imaginary part in the back. So this is the way it should look. Now, I'm not going to read all this to you because we just talked about a lot of this definition stuff. Operations with complex numbers. Now, the additive inverse, what that means is that it zeroes out the complex number. So if I have a complex number, A plus BI, then the additive inverse will do the opposite, -A minus BI. So basically it's changing the signs, okay? So let's just kind of walk through some examples and see what happened here. So look at this example. I have complex, complex, complex. And I'm combining them with adding and subtracting, right? So the first thing I want to do is get rid of the parentheses. So distribute whatever I need to. So this will be 3 plus 2i plus 4 minus I. Here I need to distribute, so it'll be -7 plus I. Now, if I combine like terms, I will have my real numbers first. So I'm going to go 3 plus 4 is 7, minus 7 is 0. That's nothing. So 2i minus 1i is 1i. 1i minus 1i, or 1i plus 1i, will give me 2i, right? So I'm back to 2i. There's my answer. So I did not have an additive inverse in this. The imaginary portion still remains. Let's look at number 2. We're just combining like terms, basically. So let's distribute what we need to get rid of parentheses. So we'll say 3, we got to distribute a negative here, plus 2 minus 3i. This will be minus 5 plus I. Now let's look at this. 3 plus 2 is 5, minus 5 is 0. Negative 3i plus I is negative 2i. So again, the additive inverse is not in there because the complex portion is still there. Look at number 3. This one's a little more complicated because it's got the radicals in there. Now we want to rewrite this in I form first. So we want to put these in standard form. So let's think through these first. Let's kind of break it down. This negative 27 is -1 times 3 times 9, right? Okay, so 5, let's see, 9 is a perfect square, so I can take out a 3. -1 is now a perfect square. I can take out the I, and that leaves me the square root of 3 inside, all right? So I've rewritten this one. I'm just going to keep the minus for now, and then I'm going to keep the -12 for now. Now 48, let's look at this. Be -4 times 12. If I keep factoring this out, that's 4 times 3. So now, if I look at this, I have 2 4s. So I can take a 4. The square root of -1 is I, and that leaves me the square root of 3. Now it's in standard form. Now I can proceed where I was before. So I will say 5 plus 3i square roots of 3. Distribute the negatives, so it'll be plus 12 minus 4i square roots of 3. Now, combine like terms. So I'm going to do my real numbers first. So 5 plus 12 is 17. Now notice that these guys are imaginary, right? And they are considered like terms because the radicals match, okay? Since the radicals match, I can combine them just fine. So this would be 3 minus 4 gives me -1i square roots of 3. And that would be my answer. But notice this one took a little bit more work, right? You got to reduce the radicals first to make them match so that you can combine them. Let's try a few more operations here. Now, 2 radicals multiplied together, so let's simplify these first. So this would be simplified by taking I out and leaving the square root of 3. 18 is 9 times 2 times negative 1, right? The negative, so the I comes out. 9 is a perfect square, so actually it's going to be a 3i that comes out. So 3i, and that leaves the square root of 2 underneath, right? So now when I multiply the outsides to the outsides, so there'd be 3i squared, insides to insides, times the square root of 6. And then I think about, can I reduce this further? Yes, I can reduce this further. So I squared is negative 1, so this becomes negative 3 square roots of 6. Now let's look at number 5. Notice these are complex numbers, so when you multiply complex numbers, you're going to use FOIL. Good old FOIL, like as if it's a binomial. So if I do my first terms, I have 8. Outer terms, I'll have plus 6i. Inner, minus 4i. And last, minus 3i squared. Let's clean it up. Let's combine like terms here. I'll have 2i minus 3. Now, I squared is negative 1, so I need to fix that. That's going to become plus 3. So 8 plus 2i plus 3. Put it in standard form. That means 11 plus 2i. Number 6, square root of 10, or negative 10 squared. All right, what does that mean? Well, that means the square root of negative 10 times the square root of negative 10. If I simplify that, it's I square roots of 10 times I square roots of 10, right? Well, I times I gives me a negative 1. Square root of 10 times square root of 10 gives me 10. So that gives me a negative 10. Maybe you looked at this and went, well, whatever's inside and you square it comes out. It's true. But if you need to break it down, you'll end up with the same answer either way. All right, let's go on to number 7. Number 7, we have imaginary times a complex. So it's just distributing. So I'll do 32i and then plus 20i squared. But then I have to simplify that because the 20i squared, remember I squared is negative 1. Negative 1 times 20 is negative 20. So I put the real portion in the front now, plus 32i. And there's my new complex number. Now, number 8 is kind of crazy. There's lots of stuff going on. We have complex numbers squared out the wazoo, right? So this first one I have to multiply out. And then I'm just going to write it out, and we'll take it step by step. I just want you to realize that you have to do FOIL here, and you have to do FOIL in the front, okay? This is going to require a FOIL, and this one's going to require a foiling. So it's going to take some space, so don't panic. We'll get through this. All right, so let's FOIL this first one. We'll have 16 plus 20i plus 20i plus 25i squared. Minus, I'm going to put parentheses here because I'm going to need to distribute that negative eventually. Let's FOIL this one. We'll have 16 minus 20i minus 20i plus 25i squared. Okay, I'm going to continue cleaning up. This becomes negative 25, right? Negative 25 plus 16 plus 40i. See, that would be negative 9 plus 40i, right? Minus, let's see what this becomes. This becomes negative 25 again. So negative 25 plus 16. This one's going to be minus 40i. So this will be minus, this becomes negative 9 minus 40i. All right. Now we're not finished. Look, we still need to distribute our negative right here. So where am I going with this? I'll have the original negative 9 plus 40i plus 9 plus 40i. All right, so where does that leave me? Well, my 9s will cancel out, and I'll end up with 80i as my answer. So it took some work, but it's not impossible. Okay, let's look at what we call complex conjugates, all right? Complex conjugates are when you have a standard form complex number, and the conjugate is the same thing with a different sign in the middle, all right? Notice that this sign is negative when the original was positive. A and B are the same, I is the same. The only thing that's changing is the negative. Now, the purpose of this is to eliminate imaginary parts of your answer. All right, so look what happens on number 9 as we multiply two conjugates together. All right, so we're just doing FOIL. So first terms 1, outer terms negative I, inner terms positive I, last terms will be negative I squared. So if they are conjugates, you're going to see this happen right here. See how they cancel one another out? Those go away if you've multiplied conjugates. So I'll have 1 minus I squared. So remember, I squared is negative 1. So this is 1 plus 1 gives me a 2. Notice the imaginary part has disappeared. What if it's not just ones? What if it looks like this? Notice they are complex conjugates because the sign in the middle has changed, and that's all. Again, if I FOIL, I'm going to do first terms gives me 16. Outer terms gives me negative 12i. Inner terms will give me positive 12i. Last terms will give me negative 9i squared. Look at my middles. These disappear, right? They cancel out. So 16, now remember I squared is negative 1, so this is really negative 1 times negative 9 is positive 9. So that really becomes a plus 9, making it 25. Now, this is especially helpful when we get into dividing complex numbers, because when you do dividing, you can't divide by an imaginary number. So what we have to do is get rid of the imaginary portion. And we're going to do that by multiplying by a funny looking 1. So I know from what we just did, if I multiply by a complex conjugate, 4 plus 2i, I can get rid of that negative part. But I can't just do it to the denominator. I have to do it to the numerator. So this is what I mean by the funny looking 1. This represents 1, right? So if I multiply this times my original, I'm not changing the value, but I am getting rid of the imaginary component in the bottom. All right, so it's just going to require some FOIL. So let's FOIL the top first. So first terms gives me 8. Outer gives me 4i. Inner gives me 12i. Last gives me 6i squared. All right, I'm just going to leave that for now. Let's do the bottom. If I FOIL the bottom, I'll have 16 plus 8i minus 8i minus 4i squared. Now, I'd always check, does my middle i's fall out? They do. Now let's clean this up. Now, 6i squared really is negative 6, right? So 8 minus 6 gives me 2. These two combine, plus 16i over negative 4i squared becomes plus 4, right? Because negative times negative makes a positive. So that becomes over 20. Now, when you do this, if you can take a GCF out of the top and simplify further, then you want to. But look, I need to do this. I need to factor a 2 out of the top. All right? Then I can cancel and divide that and make it 10. So my final answer would be 1 plus 8i over 10. All right? And that's where I would leave it. I wouldn't separate it out, just leave it as it is. Now let's look number 12. Again, I have to multiply by the complex conjugate to get rid of my negative, but what I do to the bottom, you have to do to the top. It's a funny looking 1. Now when I distribute, I will have, on the top I'm distributing anyway, 8 plus 10i. The bottom, I've got to FOIL this, so let's do that. 16 plus 20i minus 20i minus 25i squared. So the top is good to go. Not much to do there. These canceled out, right? This becomes a plus 25. So 16 plus 25 is 41. Now notice, I could take a 2 out of these two, but that doesn't get me anywhere. It doesn't help me reduce the bottom at all. So I'm just going to leave my answer just like it is. All right, let's do a couple more. Simplifying, putting in standard form. Remember, standard form is a plus bi. So this is definitely not standard form. So what I want to do is clean this up a little bit, right? Now, I to the third, let's see, negative 6. I to the third is I squared times I. So I squared will give me a negative 1, and it leaves one I left. Plus I squared is a negative 1. So let's see what happens here. This becomes a 6i minus 1. So to put it in standard form, I have to put the real parts first. So I end up with negative 1 plus 6i. What about this one? Square root of negative 75. Cubed. Cubed. All right, so be careful here. That means square root of 75 times the square root of negative 75 times the square root of negative 75. All right, there's a lot going on here. Let's reduce this all under one radical really quickly, okay? So I have a negative 1 times 75. If I reduce that down, I'll have 25 times 3. If I do it again, I'll have negative 1 times 25 times 3 times negative 1 times 25 times 3, right? That's all three of them. Now, what does that mean I need to do? Well, when I take these out, remember square roots, so perfect square of that is I, perfect square of that is I, perfect square of that is I. So I times I is negative 1 times another I is negative I. So I could take a negative I out. That takes care of that part. What's the perfect square of 25? Well, it's 5. This is 5. And this is 5. So if I multiply those out, 5 times 5 times 5 is 125. And then the 3, there's not a perfect square here, right? But if I multiply them out, 3 times 3 is 9. 9 is a perfect square, meaning I can take a 3 out, and that leaves a 3 underneath the radical. All right, so this is a hot mess, right? So let's clean it up even further. 3 times 125 is 375. It's negative because of negative I, square roots of 3. So sometimes you're going to need to break it down. Give yourself space and time to do it. Just break it on down, and you'll find that this is what you end up with. So we're going to do the in-class portion in class, but I would encourage you to try them on your own before we move forward, and we can check your work when you get to class. All right, good luck. Thank you for listening.